In our previous video, we learned about how to graph a single linear inequality. Let's learn how we will do. Let's suppose I have two linear inequalities, 2x plus y greater than or equal to 5, and the second linear inequality, x plus y greater than 3. Now to graph them, we will first find their corresponding equations. So that will be 2x plus y equals 5, and for 2 the corresponding equation will be x plus y equal to 3. Now after writing their corresponding equation, I will find the x-intercept and y-intercept for both of these equations 3 and 4. Let's first find x and y-intercept for equation number 3. For that I have to put for x-intercept I will put y is equal to 0 in 3. So I will get by putting y is equal to 0 in 3, I will get 2x plus 0 equal to 5. So x will be equal to 5 over 2, which is 2.5. So point of intersection of 3 with x-axis will be, I will give it name A, that will be 2.50. And then I will find the point of intersection of 3 with y-axis. And we know that on y-axis x is equal to 0. So I will put x is equal to 0 in equation number 3. So I will get by putting x is equal to 0 in equation number 3, I will have 2 into 0 plus y will be equal to 5. So y will be 5. So in this case, the point of intersection of the 3 with y-axis will be, I will give it name B, and that will be 0, 5. In the same way, I will find the point of intersection of 4 with x-axis and y-axis. I will repeat the same process. To find the point of intersection of 4 with x-axis, I will put y is equal to 0 in 4. So I will get x equal to 3. So the point of intersection of equation 4, which is actually a line, will be 3, 0. And point of intersection of 4 with y-axis, I will put x is equal to 0. I will get put x is equal to 0 in number 4. I will get y is equal to 3. So the point of intersection will be 0, 3. Now we get x-intercepts, y-intercepts of both the equations. Now it's time to graph them. Let's graph them. Now let's graph these inequalities. So I will just draw the points A, B, C and D on this xy plane. So first I will draw point A. Point A is 2.50, so it will be 1, 2. So 2.5 will be approximately here. So this will be my point A. Point B is 0, 5, so it will be this 1, 2, 3, 4 and 5. This will be point B. Now the line of this inequality will pass through these points A and B. So I will draw that. It will be like this. Now to draw the point C, I will draw the point C, which is 3, 0. So it is going to be 1, 2, 3. So this will be point C. And point D is 0, 3. So it will be 1, 2 and 3. This will be point D. Now I will draw the line which is corresponding for the inequality number 2. It will be like this. But if I look at the inequality, you can see here one thing which is very clear, that this is not, it's a strict inequality, it's not having a greater than equal expression. So in such cases, we will draw the dotted line. Dotted line will represent actually a strict inequality. So I will just break this line, so that will tell me that this one is actually a strict inequality here. Okay, and after that, now it is a time to shade the solution region. And to shade the solution region, of course, we need a test point for each inequality. So to shade the solution region, I will choose a test point for both the inequalities. This is inequality number 1 and this is inequality number 2. So I will choose the test point, because best test point is always 0 0. We always need any test point on either of the side of the inequality. So I will choose test point 0 0, because 0 0 is always easy test point, and it helps us to point the direction of the solution region. So first I will put for the first inequality 0 0. So I will get 2 into 0 plus 0 is greater than equal to 5. So this will be 0 greater than equal to 5, which is false, which is not true. It means the solution region of the inequality number 1 will be opposite to the origin. So that will be, I will just highlight it here with the green color. This will be the solution region of this inequality opposite to the origin, because the test point that we choose, if it will satisfy, the solution region will be in the direction of that point. But if it does not satisfy, it means it will be opposite of the test point. So this green color will be the solution region of the inequality number 1. I will highlight it in a good way so that it will be visible. Now I will choose the same test point for the inequality number 2 also. I can choose any other point also, but as I mentioned earlier also, that always the best point is to choose the origin, because origin will make the calculation easy and will take less time. So now I will choose the point 0 0 for the inequality number 2. So it will be 0 plus 0 will be greater than 3. So that will be 0 greater than 3, which is again impossible. So it means this test point does not satisfy the inequality. So its solution region will be opposite to the test point. So it will be, I will color it with this pink color. I will shade it with the pink color. I'm going to shade it carefully. While shading, shade carefully so that your solution should not be toward the other side. Now you can see here, I'm going to shade for the inequality number 2. I will not go to the other side of the inequality, as that region is not the solution region. So this all region will be the solution region now. You can see the common solution region which is appearing here black. So this will be our common solution region and will be the solution region for both the inequalities.